Before we define the term bridge constant, I wanted to do a quick review of what we get as the output of a full bridge. A full bridge, remember, has a strain gauge at each portion of the bridge. So there's no static resistors in here. Everything's a strain gauge. So this strain gauge would be sensing strain 1, this one epsilon 2, epsilon 3, and epsilon 4. And in this case, I'm going to assume that all of the gauge factors are equal, meaning that each of these strain gauges is effectively the same gauge, right? It might be positioned differently on something that I'm trying to measure, but each is the same gauge. And given this, I have my V out defined like this. I have a V in to the bridge like so. I can define my transfer function, my V out over my V in, as the gauge factor over 4 times epsilon 1 minus epsilon 2 minus epsilon 3 plus epsilon 4. Right, that is for the full bridge circuit. Right, for a half bridge, I don't have the epsilon 3 and epsilon 4 terms. Those are replaced by static resistors. So those go to 0. And I'm left with VO over VI is GF over 4 times epsilon 1 minus epsilon 2 for my half bridge. And then finally, for the quarter bridge, I am just looking at epsilon 1. So this is the kind of linearized version of that quarter bridge. I'm going to get GF over 4 times epsilon 1. And that's for a quarter bridge circuit. I can define a bridge constant that, along with the gauge factor of the strain gauges I use, provides an overall sensitivity for the entire strain gauge system. That would be including the bridge as well as the strain sensors themselves. Now, to provide a visual example of what I'm talking about with bridge constant, we can look at two cantilever beams with different bridges, but the same gauge factor for those bridges. So in this first bridge, if I add a moment on this cantilever, I'm going to see tensile strains on the top, and if these are close together, they're approximately measuring the same strain, and compressive strains on the bottom. And for this second option, where I only have a single strain gauge, I'm just looking at a single strain value there. So if I pop this into my transfer function for in this case I have a full bridge, in this case a quarter bridge, I'm going to effectively get the gauge factor times the strain for this full bridge, assuming I hook up the strain sensors properly in the bridge circuit. For the quarter bridge, I get exactly what you'd expect, just that GF over 4 times my strain. Now what this is telling me is that I have a 4 times higher sensitivity in this full bridge circuit than I do in the quarter bridge circuit. And that's ultimately what our bridge constant is going to be telling us. So bridge constant is more formally defined by the variable kappa as the output of whatever bridge circuit I have divided by the output of a quarter bridge circuit that's measuring the same strain. So for a full bridge, regardless of how things are configured, I would have GF over 4 times epsilon 1 minus epsilon 2 minus epsilon 3 plus epsilon 4 divided by GF over 4 times epsilon. And so this would give me, those GFs over 4s are going to cancel. This is assuming they all have the same gauge factor. So just give me epsilon 1 minus epsilon 2 minus epsilon 3 plus epsilon 4 divided by epsilon. So for this example, in looking at bridge constant, I have a beam of material that's that's an axial force is being applied to, and I'm going to have two strain gauges here. One is along that axial direction, and the other is kind of oriented transverse to the force that's being applied. So this one is going to see strain. This one will see minus nu times my strain, where nu is my Poisson's ratio. And in this case, I have two strain gauges So I have two strain gauges in my bridge circuit, and in this case I've oriented them or organized them in this way. So I have one strain gauge in this quarter of the bridge, another strain gauge over here, and then resistors down here. Otherwise V out and V in look pretty much the same. And then this is strain gauge 1, and this one is strain gauge 3. So given that, I can calculate what the bridge constant is for this particular topology. So kappa in this case is epsilon 1 minus epsilon 2 minus epsilon 3 plus epsilon 4, and that's divided by epsilon. In this case, epsilon is going to be my axial strain as well. So here epsilon 2 is 0, epsilon 4 is 0, so I'm just left with epsilon 1 and epsilon 3. And this kappa is going to be, epsilon 1 will be my basic axial strain, minus epsilon 3, so I'll have plus nu of that axial strain divided by my axial strain. So my bridge constant here is 1 plus my Poisson's ratio. So this quantity, this kappa or bridge constant, along with the gauge factor of these sensors that I have on this beam, will ultimately determine the sensitivity, the V out, that I get for a given V in and strain of this particular circuit.